Hello my dear students, let us start our today's class with solution of assignment 5. Now first question is, area below VT graph is a measure of, and the answer will be option B, that is displacement. Question number 2, if VT graph is straight line inclined to the time axis, then the answer will be option C, that is A is constant. Next, question number 3, acceleration of a body whose VT graph is parallel to time axis is 0. Answer will be 0. Now next question, the negative slope of ST graph indicates retardation motion, and here the answer will be false. See students, here negative slope of VT graph indicates retarded motion, means here if VT graph is given, then answer will be true, but here distance time graph is given, that's why the answer is false. Now next, question number 5, the displacement of the body in 5 seconds from the beginning of the motion is. Now here you have to calculate, if you want to find out the displacement, we have to calculate the area under the graph. For first 5 seconds means we have to consider the triangle OAC. Clear? So the area of triangle OAC is half into base into height, and here base is OC, that is equals to 5 seconds, and height AC equals to 20 meter. So you just substitute the value and displacement will be 50 meter. Clear? Now if instead of 5 seconds, 10 seconds is given to you, then you have to calculate the area under the triangle OAB. Then the total area will be 50 plus 50, that is 100 meter. Clear? Now let us start our today's topic, derivation of motion by graphical method. Now before we start our today's topic, we have to remember equation of motions are applicable only for the bodies who are moving with uniform acceleration. Means if acceleration is constant for a moving body, then the equation of motions will be applicable for them. Now let us start our today's first topic, that is derivation of first equation of motion from VT graph. This equation is also known as equation for velocity time relation. Remember this. The first equation is also known as velocity time relation. And the first equation is V equals to U plus AT. Now our target is to derive the equation from the graph. To derive this, here we have considered the velocity time graph of a uniformly accelerated motion of the body having initial velocity, that is U, and final velocity, that is V. And it is shown in the figure here. Now here the VT graph is a straight line AB, and we will calculate the acceleration of the body. Now acceleration of the body is change in velocity and time taken for the change. See from the graph, what is the change in velocity? Initial velocity is U. While time is t equals to 0, that is the origin, you just see initial velocity is OA, that is U. And after time t, at the when the object is at B, the final velocity is represented here by either BD or OE, that is V. Clear? So what is the change in velocity? Change in velocity from the graph, if you want to measure, you have to draw two perpendicular on two axes. One axis to on the time and another perpendicular to the velocity axis. So the perpendiculars here are BD and BE. So what is the change in velocity? Change in velocity will be CB and time taken is AC. Clear? Now CB, if you just subtract DC from BD, you will get CB. And what is dB here? dB is the final velocity, that is V. And what is the CD here? CD is the initial velocity, that is OA equals to U. So, and OD is the time taken for the change. Just substitute all the values. What we will get? Acceleration A equals to V minus U by T. Okay. Now just cross multiply AT. We will get AT equals to V minus U, and rearrange them. What we will get? V equals to U plus AT. So this is our first equation of motion, which is also known as velocity time relation. Okay. Now we will discuss second equation of motion from VT graph. This equation is also known as position time relation, and the relation is S equals to UT plus half of AT square. Here S is the displacement, U is the initial velocity, T is the time taken for the displacement, and A is the uniform acceleration. Now to measure the displacement during the time T, we can calculate the area under the AB graph, and that is the area of the trapezium OABD. Now this area of the trapezium we can divide into a triangle and a rectangle, and the triangle here is ABC and the rectangle is OACD. Now if we separately calculate their area and add them, we will get the total AB, that is of the trapezium OABD. Now see, here distance travelled S equals to area of triangle ABC plus area of rectangle OACD. Now what is the formula of area of triangle? You know, half into base into height, and for rectangle, length into breadth. For the triangle, base here we have considered AC as base of the triangle and CB as height of the triangle. So area of the triangle is half into AC into CB. And for the rectangle, length is OD and breadth is OA. So area of the rectangle is OD into OA. Now see here, what is AC? That is equals to OD, and that is equals to time T, means AC equals to OD equals to T, and see, CB, the height of the triangle, is equals to BD minus DC. And what is here DC? DC is the initial velocity, that is equals to OA. And what is DB? DB is the final velocity V. Therefore, CB will be DB minus DC, that is equals to V minus U. And here OA is the initial velocity, that is U. Now, the distance travelled here is, we will just substitute all this value, and what we will get? S equals to half into T into V minus U plus T into U. So multiplying all the terms, what we will get? S equals to UT plus half of V minus U into T. Let us give this equation as number 2. Now from the first equation of motion we know V equals to U plus AT. Just rearrange them, what we will get? V minus U equals to AT. Now we will substitute this value of V minus U in equation 2, and what we will get? S equals to UT plus half of AT square. Clear? This relation is also known as, you remember, position time relation. Clear? Now, if let us consider a special situation. if velocity of an object is constant. If velocity is constant means there is no change in velocity. Therefore, acceleration a is equals to 0. So, if a is 0, you just substitute in this equation, what you will get? A is equals to ut plus 0, that is a is equals to ut. Okay. So, if no acceleration is there, means if any object is moving with constant velocity, then what is our formula? A is equals to u, constant velocity, into time, that is a is equals to u into t. Now we will start our next derivation, that is of third equation of motion from VT graph, and this third equation is also known as position velocity relation. Now let during the time period t, the velocity changes from u to v, as we have considered for this situation. Initial velocity is u and final velocity is v. Here also we will start to calculate distance traveled during this time. And what is the distance traveled? That is A is equals to area under VT graph. Or here also this distance traveled will be area of trapezium OABD. So distance traveled here A is equals to area of the trapezium OABD. So formula is A is equals to half into OA plus BD into AC. Now here OA is equals to initial velocity u, BD equals to the final velocity v, and AC equals to OD, that is time t. Now equation 1 will become then AC equals to half into u plus v into t. Now from first equation of motion we know v equals to u plus at or v minus u equals to at, or time t is equals to v minus u by a. Now just put this value of t in equation 2, we will get a is equals to half of u plus v into v minus u by a. Just cross multiply and we will get equals to v plus u into v minus u. And we know v plus u into v minus u equals to v square minus u square. Now next rearrange them, and what we will get? V square equals to u square plus 2as. And this is our third equation of motion, and this equation is also known as position velocity relation. So this much is for today's class. Thank you.